Welcome back. In the last video on the Captain Fantastic pinball machine conversion, I talked about having this board designed and built. Since then, we have sent the design off, had the board manufactured, gotten it back, tried to build it. I had great difficulty with these SSOP form factor IC chips. They are just so tiny that I had a lot of problems with solder bridging and stuff like that. I was using a hot air gun to build the board, and I just had terrible luck. I did manage to get a few of them working, but the board was good enough to point out a few design flaws. And that's why you have proto boards built, is so you can find these design flaws. One of the biggest ones, and I doubt if you can see it on here, but right there on each of the chips I have a pin lifted. That is the reset pin, and I had accidentally tied it to ground, which forces each of those chips into the reset mode. By disconnecting the pins, or I just actually ground them off with the Dremel tool, I was able to get some of them to enable, but not very well. I also found the problem, a wiring problem that I fixed on the back of the board. Ugly, isn't it? But I fixed that, and that was the pins that I had chosen for the I2C interface. I couldn't get the second I2 interface to work, so I moved it back to the first I2C interface. So basically, this board was a good learning experience, but it didn't work. Another thing that I noticed that we had forgotten, if you see that resistor there, if you look at any of the documentation about these boards, they don't work with the USB unless you add a 1.8k ohm resistor across the USB, and I wanted to put that on the board and forgot. So that one is just soldered across there, but we had another board built. So here is the new board. We swapped out the SSOP chips for SOIC chips, which are considerably larger form factor. I put these on and I reflowed them in a toaster oven, just a plain old toaster oven, no controls or anything. I ran it for about 4 minutes at 350 degrees and cranked it up to max until the reflow occurred. Turned it off, let it cool down, and it worked perfectly. We've made quite a few changes to this board. To start off with, you can see here that we have a couple of 8-bit dip switches, and those are for inputting options for gameplay, like, ease of use and things like that. We don't know for sure what we're going to do with them yet, but they are there. We've added some LEDs here. There's just a blue power LED, there's a green OK LED, and there's a red error LED. I run a short little diagnostic program that simply checks to make sure that the processor can talk to all of the port expander chips, and if it can, then it turns on the green light and continues on with enabling those chips and going about its work. If it can't, it turns on the red light and it stops and doesn't do anything. Another change, it isn't actually implemented because I haven't received the chips yet, but I've added a small EEPROM on here to hold configuration information, high score, stuff like that as the games are played. We're not sure what we're going to do with that either yet, but we will certainly find something to do with it. So this board worked perfectly. I put everything down, and there were a few minor mistakes, some solder joints I forgot to solder and things like that, but other than that, it works fine. I have not figured out how to get the interrupt service routines to work, but I'm still working on that. It's my first time trying to get the interrupts working. I can read the pins without any problem. It just the interrupt locks it up when the interrupt occurs. So I will work on that in the future and try to get that ironed out. Right now I have some code in here that just steps through and activates each of the relays. You notice we have some mechanical relays down here at the bottom, and then we have some solid state relays up here at the top. The Captain Fantastic pinball machine has mostly AC solenoids in it. However, it does have 5 DC solenoids, and these solid state relays can only switch AC. They can't switch DC. So we put in the mechanicals to switch the 5 DC solenoids. So I'm going to plug this in. I'm going to set the phone down, or I'm going to stop the recording, plug this in, and I'll bring you back in a second. Okay, so here it is running. You can see the lights blinking on the relays as it goes across. You can hear these guys click, and then you can just see the light running on the back there. You can see it's really swamping out on the camera, but you can see the blue power LED and the green OK LED right beside it here. It's kind of hard to see green on green board with a green LED, but that is the output connector where the LED strips will be connected in the future. We have room for one more solenoid board on the bottom, and we've utilized these connectors to input these switches, but we have 2 more connectors over here where we could have yet two more relay boards if we wanted. So right now we don't need them. I don't think we will even need the board that goes here. So we'll see as we develop our wiring strategy for the board exactly how many of these we'll need. But thanks for watching.